Moving the moon 10 times closer to Earth would shrink the distance from roughly 384,400 kilometers to a mere 38,440 kilometers. This is just slightly above the altitude where our telecommunications satellites orbit. While a massive, detailed moon hanging in the sky sounds like a dream for photographers, for the Earth, it would be a waking nightmare of gravitational violence. Here is the breakdown of the lunar proximity apocalypse. 1. The sky, a colossal neighbor. The first thing you would notice is the visual scale. Because the moon is 10 times closer, it would appear 10 times larger in diameter and 100 times larger in terms of surface area in the sky. It would dominate the horizon, covering a massive portion of the heavens. You would be able to see craters, mountain ranges, and valleys with the naked eye as clearly as if you were looking through a high-powered telescope today. 2. Tides. The global wash cycle. This is where the destruction begins. The gravitational pull, tidal force, follows the inverse cube law. If the distance decreases by a factor of 10, the tidal force increases by 10 cubed, or 1,000 times. Kilometer-high waves. Current tides move the ocean by a few meters. A 1,000 times increase would create bulges of water kilometers high. These wouldn't be waves in the traditional sense. They would be massive moving hills of ocean that would sweep across entire continents twice a day. Coastal erasure. Every coastal city on Earth, New York, London, Tokyo, Mumbai, would be erased within the first 6 hours. The water would penetrate hundreds of miles inland, scouring the landscape down to the bedrock. 3. Land tides and super earthquakes' gravity doesn't just pull on water, it pulls on the solid Earth. At this distance, the moon's gravity would stretch and distort the Earth's crust by dozens of meters. Tectonic agony. This constant squeezing and stretching would generate massive internal friction, heating the Earth's mantle. This would trigger global volcanic eruptions and earthquakes of magnitudes never before recorded, 10.0 plus on the Richter scale. The ground would essentially behave like a liquid. 4. The Roche Limit, the final act. The moon's survival is also at stake. Every celestial body has a Roche limit, the distance at which a planet's tidal forces are stronger than the gravity holding a satellite together. For the Earth-Moon system, this limit is roughly 9,500 to 18,000 kilometers. While 38,000 kilometers is still outside the immediate disintegration zone, the moon would likely begin to deform into an egg shape. However, if the moon were to spiral any closer, it would be torn apart by Earth's gravity. The ring of Earth. The moon would shatter into billions of pieces, forming a spectacular glowing ring around the Earth, similar to Saturn's. While beautiful, these fragments would eventually rain down on Earth as a continuous bombardment of meteors, sterilizing the surface. 5. Atmospheric drag and the death spiral. At 38,000 kilometers, the moon would be moving much faster to maintain its orbit. Kepler's third law. It would orbit the Earth every few days instead of every 27. The friction from the very outer edges of our atmosphere and the massive energy transfer from the tides would act as a brake, causing the moon to slowly spiral inward. The collision would be inevitable, the 1,000-year aftermath. A shattered world and a ring of dust. If the moon were moved 10 times closer and stayed there for a millennium, the Earth would be unrecognizable. The initial cataclysmic floods would have settled into a new, terrifying normal. By the year 3026, the Earth-Moon system would have reached a state of terminal instability. Here is the long-term outlook for a moon that is 10 times closer. 1. The slowing of the Earth. 100-hour days. Tidal friction is a powerful brake. Currently, the moon's tides slow Earth's rotation by about 2 milliseconds per century. With the tidal force increased 1,000 times, this braking effect becomes extreme. The braking effect: within 1,000 years, Earth's 24-hour day would have stretched significantly. The planet would be losing hours every decade. Tidal locking. Eventually, the Earth would become tidally locked to the moon, meaning the same side of Earth would always face the moon. One half of the world would see a permanent, gargantuan moon. The other half would never see it at all. 2. The death of the oceans and tidal deserts. The water wouldn't just be high or low. The sheer mass of the water being dragged around the planet would change the geography of the Earth itself. The scoured Earth? After 1,000 years of kilometer-high tides, all soil would be stripped from the continental plates near the coasts. The habitable land would be restricted to the centers of large continents or high-altitude plateaus like Tibet or the Andes. Atmospheric drag. The moon is now so close that it's beginning to brush against the very thinnest outer layers of the exosphere. This creates a tiny but constant drag, causing the moon's orbit to decay. It is no longer staying at 38,000 kilometers. It is slowly spiraling inward. 3. The ring transition, the Roche limit. As we approach the 1,000-year mark, the moon's structural integrity fails. The stretching. The moon is no longer a sphere. Earth's gravity has stretched it into an oblong, egg-like shape. Giant fissures miles deep open up across the lunar surface as the moon is literally pulled apart. Fragmentation. Once the moon crosses the Roche limit, it doesn't hit the Earth as a solid ball. Instead, it shatters. Billions of tons of lunar rock would spread out into a massive shimmering ring around the equator. 4. Earth as a ringed planet. By the end of the millennium, the moon as a single object is gone. The shadow. The new rings would cast a permanent shadow over the Earth, plunging the tropics into a cold, dark winter and disrupting what remains of the global climate. The meteor rain. The inner edge of the ring would constantly decay, sending moon rocks raining down into the atmosphere. Every night would feature thousands of brilliant fireballs, but the surface would be a hazardous zone of constant impacts. 5. The biological vacuum life, as we know it, would likely be extinct or forced into extreme deep sea or deep underground refuges. Photosynthesis. Failure: the dust and ash from constant volcanic eruptions, triggered by the land tides, and the shadow of the rings would block significant amounts of sunlight. Evolutionary reset. If life survives, it would be adapted to a world of extreme pressure, constant seismic vibration, and a 100-hour